Come on, my dears, let us proceed further in chapter number 8. Today we will finish the theoretical portion and then after we will begin the MCQs from exercise. Okay. Now, in the further discussion, the article from theoretical part is, look at the title, Reflection of Wave from Free End, or from free support, you can say, from free support, from free support. Consider this as some rod, okay. So, everywhere in the figure, this one is vertical rod. We have one ring whose diameter is slightly greater than diameter of this rod, okay. That is why you can see here this ring which is slightly wider than the external diameter of the rod, correct. Now, this ring, because it is slightly bigger, can slide over this rod very freely, okay. We have tied one string with this ring and that string is like this, look. Now, what we do at this very end, we just produce one pulse. That pulse is produced this way. We just shake the string vertically upwards and then downwards this way, correct. So, we just produce only half of the wave, that is pulse, and that pulse is produced in the form of crest, and that crest is traveling this way, correct, fine. That crest is made incident on this support, but the another end of the string is tied with this ring. Now, tell me, the moment the pulse is made incident on this ring, that very moment the situation or the shape in the ring is like this. The situation or the shape produced in the string is like this, look. So, you can see now the wave is made incident in the form of crest. Now, tell me, this amplitude I am taking as capital A, correct, fine. Now, for this incident wave, because it is propagating towards negative x-axis, then we can write the wave equation like this: yi equals to a sin omega t plus kx, I for incident, correct. And why I am writing here plus a? Because it is made incident in the form of crest, that is why plus a. And because it is propagating towards negative x-axis, I must write here plus sign. Simple, fine. This is the situation at time t equal to 0. Now, when you shake the string like this, upwards and downwards, total time taken for this oscillation is capital T. So, we are breaking capital T into 4 equal intervals of time: 0, then t by 4, then t by 2, then 3t by 4 and then capital T. This is the situation at time t equal to 0. At time capital T by 4, at time capital T by 4, what has happened? I am showing you. Because of the force given by the tension produced in the string on this ring, it so happens it now starts sliding upwards. It slides upwards this way. At the time capital T by 4, this ring is found to be here, correct, fine. Now, tell me, at the end of time capital T by 2, the ring has reached to this highest position where this upper displacement is 2a, correct. It is double than this amplitude, fine. But then when the ring reaches at the highest position, for a moment its velocity is 0, for a moment. Then after it is coming downwards, fine. At the end of time equal to 3t by 4, this is the situation. At the end of time capital T, this is the situation. Now, tell me, at the end of one oscillation, that is at the end of capital T time, you are going to get this wave, then after it is going to be reflected this way towards right hand side. Now, the shape you can see it is still in the form of a crest. So, when this crest is made incident, the same shape, same crest is getting reflected. But note it very carefully. The support from which it is reflected, it is not a fixed support, it is easily movable support, it is a free support. So whenever wave is getting reflected from free support, its shape does not change, crest remains crest only. But direction of propagation of wave is now getting reversed. Now it is propagating towards positive x-axis, and then here we should write minus sign in the wave equation. What was the wave equation for a wave propagating towards positive x-axis? Y equals to a sine omega t minus kx, correct? But because it represents reflected wave, I should write here YR, R for reflected, correct? So have you noticed one thing here? Whenever any wave is reflected from free support, its shape does not change. That's why here also I am writing plus A, here also I am writing plus A. If crest is made incident, then crest is getting reflected. If a trough is made incident, then trough will be getting reflected. No change of shape when wave is getting reflected from free support, correct? Only direction of propagation is getting reversed. Earlier it was negative x-axis, now it is towards positive x-axis. Simple? Fine. Let us proceed further. The last theoretical topic in the chapter. It is about Doppler effect. Not only this effect is very important in physics, it is also very important from examination point of view. Doppler effect. There was a scientist with name Mr. Doppler. He had noticed one phenomenon, and then after he only had explained this phenomenon properly. So in his memory we call this phenomenon as Doppler effect. Now what is that phenomenon? I am showing you, listen now. Consider me as a person who is going to hear, who is going to listen some sound. If any person is listening sound, you can call him as a listener, okay? Suppose I am as a listener standing at rest here, okay? At some distance from me, you just consider some ambulance van, okay? In the roof of which there is fitted some siren, and if you switch on that siren, if you blow that horn, then it produces sound. When you switch on the siren, it may produce sound like this. Correct? Any object which produces sound, we can call it source of sound, okay? In short, we will call it source, okay? It is a source for the production of sound waves, okay? Suppose ambulance 1 is at rest, that is source is at rest, and listener is also at rest. At that time, whatever sound is heard by the listener, its frequency is just the same as frequency of sound generated from the source, correct? Frequency of sound generated from the source and frequency of sound heard by the listener, both of them are equal when both of them are at rest, meaning thereby when there is no relative motion between source and listener, at that time frequencies are equal, correct? Fine. Now let us have some relative motion between them. You can have relative motion between source and listener in 6 different ways. Which 6 different ways? I am showing you. Suppose listener is at rest and only source is in motion. Then you can think of 2 possibilities. Source may move towards this listener or it may move away from the listener, correct? Which are other 2 possibilities? Suppose source is at rest and listener is in motion. Again 2 possibilities. Listener may move towards the source or it may move away from the source, correct? Still you can think of 2 more possibilities. Which two? I am showing you. This is a source, this is a listener. Both of them may move towards each other or both of them may move away from each other. Correct? So, in all 2 plus 2 plus 2, that is 6 possibilities you can have regarding relative motion between listener and source. Correct? Now, in every possibility, there is some relative motion, and because of relative motion, what will happen ultimately? Either distance between listener and source will decrease or it will increase. Either distance will decrease or it will increase. Correct? Now, practically what do we find? When distance is decreasing, this frequency of sound heard by listener is found to be greater than the frequency of sound actually generated from the source. Then you may ask, sir, how we can experience, how we are sure that we are hearing a sound with greater frequency? Yes, when a sound is having greater frequency, it is found to be very sharp, very sharp. So, if sharper sound is heard, you can say frequency has been increased. Okay, fine. Now, if because of relative motion, the distance between listener and source is increasing, suppose, then at that time practically we notice that frequency of sound heard by the listener is found to be smaller than frequency of sound actually generated from the source. How we are sure that frequency has been decreased? Whenever frequency decreases, at that time remember the sound is heard very deeper. So, if deeper sound is heard, that is less sharp, then we can say frequency has been decreased. Okay? When frequency of sound wave increases, sound is heard sharper, and when frequency of sound is decreasing, sound is heard deeper, that is less sharper. It is called deeper sound. Got it? The lady's voice is sharper and gent's voice is deeper. Lady's voice is sharper, lady's voice is sharper, and gent's voice is deeper. Got it? This is the difference in the musical note produced by lady and produced by gent. Got it? Fine. Now, this sort of change in frequency of sound occurring during relative motion between listener and source, that was noticed first by Mr. Doppler. In his memory, we call this phenomenon as Doppler effect. Okay? So, let us now prepare the statement of Doppler's effect. Whenever a source of sound or listener or both of them move relative to stationary air medium and relative to each other, comma, the frequency of sound heard by the listener is found to be somewhat different than the frequency of sound actually generated from the source. This very phenomenon is only known as Doppler's effect. I repeat, whenever source of sound or listener or both of them move relative to surrounding stationary air medium and relative to each other, the frequency of sound heard by the listener is somewhat different than the frequency of sound actually generated from the source. Full stop. This very phenomenon is known as Doppler's effect. Now, last time, what is called Doppler's effect? Listen now. When source of sound or listener or both of them move relative to stationary air and relative to each other, then frequency of sound heard by listener is found to be somewhat different than the frequency of sound actually generated from the source. Full stop. This very statement is called Doppler's effect. Correct? Now we want to derive the expression for frequency of sound heard by the listener in each of the 6 possible cases of relative motion. Just now I told you, in each case what should be the frequency of sound heard by the listener. We want to obtain its value, but for that we must derive its formula. Okay? So let us go for deriving that expression now. Try to understand the figure which I have drawn on the board very clearly, please. Take this pink colored dot as a source of sound. What is this pink colored dot? Source of sound. It is located at point O at time t equal to 0. At time t equal to 0, it is located at point O. Correct? Suppose that source of sound moves towards right hand side this way with a constant velocity Vs, that is velocity of sound waves. Sorry, velocity of source. Velocity of source. Velocity of source. Fine. Now let it move for the time interval equal to periodic time of sound wave. What is periodic time of sound wave? That is time taken by particle of air medium to oscillate only once. Time taken to complete one oscillation during the propagation of sound wave is called periodic time of sound wave. You know, when sound waves propagate, what happens? The air particles simply oscillate about their mean positions, which is parallel to direction of propagation of sound wave. At that time, whatever time is taken by air particle to complete one oscillation is called periodic time of sound wave. Let it be shown by symbol capital T. So how much time interval we are taking into consideration? Capital T. Fine. At the end of capital T time, this source of sound wave, suppose it has come over here, correct? At which new position? New position is shown by symbol O dash. So distance O dash is travelled by source of sound in a time equal to capital T, that is periodic time of sound wave, correct? Now what do you mean by distance travel? If velocity is constant, then distance travel is nothing but constant velocity into time. Constant velocity into time. Constant velocity of source I am taking Vs, and into time interval which we have taken into consideration is capital T. So this distance is constant velocity into time. Constant velocity into time. Okay, fine. Now tell me, what is the job of this source of sound wave? Job of source of sound wave is to emit sound waves, correct? The very first sound wave generated from the source has come on the left side, say up to position B at the end of capital T time, and the one which is emitted towards right hand side, that first sound wave has come over at position A at the end of capital T time. What I mean to say, the first sound wave emitted from the source, it travels this much distance on left side and this much distance on right side. But because in both the directions the velocity of sound is same, then this distance OA and this distance OB are same. OA equals to OB equals to how much? You know, distance travel is constant velocity into time. Constant velocity of sound wave we are taking as small v into time. Time we have taken into consideration capital T. So constant velocity is v, time is capital T. So this much distance is v into t. V into t. Similarly, distance OA is also v into t, but we are not showing in the figure. In the figure we have shown distance OB, which is v into t. Correct? Fine. Now tell me, by the time capital T time is over, the source is not at O. Source has come to the new position which is O dash. So at the end of capital T time, source has come at position O dash. At that time it emits a second wave, correct? Because time interval taken between emission of two successive waves, it is periodic time. So at time t equal to 0, the source had emitted first wave. At the end of capital T time, now it is emitting second wave. That second wave in the figure I have shown with the blue color. Okay, fine. Now tell me, first wave at the end of capital T time has come over here. The second wave is just now generated at time capital T. It has been recently generated. It is here. And what is the distance covered between two successive crests? It is called wavelength of the wave. the crest of first wave has come over here at position B, and the crest of second wave is here at O dash. So at time capital T, the first crest has come over here and the second crest is here, and distance between two consecutive crests is going to give you wavelength. So this distance from B to O dash will give you wavelength. So from B to O dash, this much distance is going to give you wavelength, let it be lambda. And that wavelength, which is distance between two consecutive crests, will be this much distance, and it is nothing but summation of these two distances. What is this? Come on, V into T plus what is this? Vs into T, correct? So this will give you wavelength of sound waves which are propagating towards left side this way. Okay, fine. Now tell me, we just consider a listener shown by symbol L who is going to hear that sound, and suppose this listener is moving towards right hand side, that is towards these sound waves with velocity say VL. Okay, so don't get confused between three different velocities. I am just repeating. What is small v? Velocity of sound wave. Here it is. V is velocity of sound wave, correct? What is VL? VL is velocity of listener. VL is, look here, velocity of listener. What is Vs? Vs is velocity of source. Vs is velocity of source of sound. Okay? It's not velocity of sound, velocity of source of sound. Velocity of source of sound. So for velocity of sound is concerned, it is only V. V is velocity of sound, VL is velocity of listener, and Vs means velocity of source. Got it? And here, for the discussion of this topic in our syllabus, we are going to assume one condition, and that condition is this: V is greater than VL, at the same time V is also greater than Vs. In short, among three velocities, V is biggest. Velocity of sound, we considered this moment greater than velocity of listener, greater than velocity of source. V is greater than VL, V is greater than Vs. Got it? Fine. Now tell me, let us find out the relative velocity of these sound waves, with respect to listener. Let us find out. Look, before that, let us find out this lambda in terms of frequency of source. I am showing you. Lambda at present is this much distance, correct? This much. This much means how much? It is distance between consecutive crest. Distance between two consecutive crests. It is wavelength, lambda. And it is this much distance means this plus this. So I am writing here V into T plus Vs into T. Come on, take T common. Take T common, then inside the bracket V plus Vs. Inside the bracket V plus Vs into T, correct? Now don't you know periodic time is reciprocal of frequency? Periodic time is equal to reciprocal of frequency. This is the periodic time of sound wave generated from the source. It should be equal to reciprocal of frequency of sound generated from the source. Let it be Fs. Fs is the actual value of frequency which is generated from the source, correct? Frequency of sound generated from the source, I am taking Fs. You know periodic time is 1 upon frequency, which is Fs right now. So in place of T, we can write 1 upon Fs, write it here. In place of capital T, we can write 1 upon Fs, 1 upon Fs, correct? So lambda is this much, fine. And now let us find out velocity of these sound waves propagating towards this listener. With respect to listener, what is the relative velocity of sound waves? Let us find out, okay? Now in textbook, they have written directly that relative velocity will be V plus VL. But how it is V plus VL, I am showing you. Recall first semester, you had studied that velocity of A with respect to B. Velocity of A with respect to B. What was that? It was VA minus VB. Remembered? VA minus VB. Remembered? Fine. Now we want here velocity of sound waves. Velocity of sound waves. Velocity of sound waves with respect to listener. Velocity of sound waves at present I am showing by symbol VA. With respect to listener. With respect to listener. Now tell me, according to this definition, Can you rewrite this way? It should be VA minus VL. Any problem? Fine. Now tell me VAL as it is, that equals to VA. Now VA means what? Velocity of sound waves at this moment. This is velocity of sound waves, let it be V minus velocity of listener. Now look in the figure. Listener is moving with velocity VL, but in which direction? In a direction opposite to direction of propagation of sound waves. Because direction of VL is opposite to V, if we are taking as positive, then VL should be taken negative. So instead of VL, I am putting minus VL. Correct? Now tell me minus minus will become plus. So it is now V plus VL. V plus VL. Tell me, what is this? Velocity of sound waves with respect to listener. Velocity of sound waves with respect to listener. In this case, how much it is? V plus VL. Come on. Velocity of sound waves with respect to listener. How much it has come out to be? V plus VL. So that relative velocity I am writing V plus VL. Correct? And that relative velocity you are finding for those sound waves which are approaching towards listener. So listener will hear that sound. So he will experience some particular frequency of sound waves. And that frequency of sound waves as heard by this listener, I am showing by symbol FL. Correct? FL means what? Frequency of sound heard by the listener. And this is the wavelength of those sound waves which are approaching towards this listener. Correct? And don't you know, velocity of propagation of wave is equal to frequency multiplied by wavelength. Frequency multiplied by wavelength. I repeat, what is V plus VL? Relative velocity of sound waves with respect to listener. What is FL? Frequency of sound heard by the listener. What is lambda? Wavelength of sound waves approaching towards the listener in this case. Correct? Fine. Now tell me, this V plus VL as it is, FL as it is, but what about lambda? Lambda formula just now we got it. What is the formula? It is V plus Vs upon Fs. V plus Vs upon Fs. Lambda is V plus Vs upon Fs. Lambda is V plus Vs upon Fs. Okay. Just rearrange the terms again, and you will have one very good formula which you can remember very easily. Just rearrange it, the terms the way I am showing you. Look, FL upon V plus VL. Take it this way, FL upon V plus VL. FL upon V plus VL, you can write equal to Fs upon V plus Vs. Fs upon V plus Vs. Fs upon V plus Vs. You can just pick it very easily now. FL upon V plus VL equals to Fs upon V plus Vs. FL upon V plus VL equals to Fs upon V plus Vs. Last time, FL upon V plus VL equals to Fs upon V plus Vs. This is the standard format. We are going to use the same format in the numericals. So please remember, just give me identification of each symbol. What is FL? Frequency of sound heard by the listener. What is Fs? Frequency of sound actually generated from the source. What is V? Velocity of sound waves. VL is velocity of listener and Vs is velocity of source. Got it? Fine. Now here we are going to adopt the sign convention regarding the signs of three velocities. One is V, another is VL, third is Vs. Among these three velocities, which velocity should be taken positive, which velocity should be taken negative? For that, we have preferred one sign convention. And if you follow that sign convention, then the calculation would become very easy. Not only that, for all the possible 6 cases of relative motion between listener and source, in each case you can apply same formula. Using same formula, every time you can find out frequency of sound heard by the listener. Correct? So it will become very easy for us if we adopt that sign convention. Sign convention is also very simple. You need to remember only two rules. Which are those two rules? I am showing you. Very simple. Look here. I am writing here sign convention. Correct? This V is what? Velocity of sound waves. That is to be taken always positive. Irrespective of given situation in the problem, every time you must take velocity of sound every time positive only. So V should be taken always positive. Okay? Now two velocities are left out. Which two velocities? VL and VS. Among VL and VS, which should be taken positive? Which should be taken negative? I am showing you. Suppose here is listener. Correct? I am writing here listener. L for listener. Suppose here is source of sound wave. I am writing here source of sound. Okay? S for source, L for listener. Not necessary that you also must think like this. You may show this source over here on the left side also. No problem. Correct? But suppose this is the case. Listener is here, source is here. Now every time for given situation, every time what you should take? Velocity in a direction from listener to source should be taken positive. Any velocity out of VL and VS, whichever velocity is in a direction from listener to source, it should be taken positive. And if it is opposite, should be taken negative. Velocity in a direction from listener to source should be taken positive. Then opposite velocity should be taken negative. Simple. Just tell me both the rules again. Velocity of sound waves small v is to be taken always positive. Correct? Now out of remaining two velocities VL and VS, which should be taken positive, which should be taken negative? Very simple. Velocity in a direction from listener to source should be taken positive. If opposite, then it should be taken negative. Simple. Fine. Now let us just understand this special note. During the propagation of sound wave in air medium, we have assumed here that whole air medium as a whole, it is at rest. That is what we have assumed, but not necessary. In the practical conditions, there may have some wind, you may have some wind. If wind is blowing, then again we can think of two possibilities. If sound waves are propagating this way, suppose, and the wind is also in the same direction, then what should be the resultant velocity of sound waves? It should be taken V plus VW, V plus VW, where VW is velocity of wind. Because both of them are in same direction, we must add. This is velocity of sound wave. This is also in the same direction, we have got velocity of wind. Because of same directions, we should add them. Then in place of V, in this formula, in place of V, we should write V plus VW, because VW is the velocity of wind. It is in the same direction of velocity of sound. Okay? Same direction, then addition. Suppose opposite direction. Say sound waves are propagating towards right side, and suppose wind is blowing towards left side, suppose. Then because of opposite direction, you must take subtraction, V minus VW, correct? Same direction, then addition, opposite direction, then subtraction, okay? So if wind happens to blow in a direction opposite to propagation of sound waves, then instead of V in this formula, we must replace V by V minus VW, correct? Now, out of 6 possibilities regarding relative motion between listener and source, let us consider 2 possibilities. Look, suppose listener and source, both of them are moving towards each other. They are heading towards each other, correct? They are heading means they are moving towards each other. Fine. Velocity of listener, we will show by symbol VL. It is towards the right hand side in the figure. And velocity of source we will show by symbol Vs, and it is towards left side. Okay. Now what was the sign convention? I told you, velocity in a direction from listener to source, should be taken positive. Velocity in a direction from listener to source should be taken positive. Now tell me, this velocity of listener is in the same direction. So I should take VL as positive. But because this direction is opposite to this, I must take it negative. Correct? So you should treat VL as positive and you should treat Vs as negative in this formula. Correct? So make these changes in this standard formula. Then FL upon V plus VL, FL upon V plus VL should be equal to Fs upon V plus Vs. Fs upon V plus Vs, but instead of Vs I should write minus, because this velocity is opposite to the direction shown in the sign convention. Correct? Velocity in a direction from listener to source should be taken positive, but because this velocity is opposite to this, I must take it as negative. So instead of Vs in this formula, I should write minus Vs. Simple. And now find out FL, make it subject of the equation, transfer this. So FL equals to V plus VL upon V minus Vs, V plus VL upon V minus Vs into Fs. Don't forget this Fs. Okay. Here also there is V, here also there is V. In numerator you are making addition, so its value will increase. In denominator you are making subtraction, value will decrease. So compared to denominator, right now numerator is greater. Because numerator is greater than denominator, then this ratio is greater than 1. Because this ratio is greater than 1, then FL will be greater than Fs. What is this bracketed part? It is coefficient of Fs. And if this coefficient, this multiplier is greater than 1, then FL must be greater than Fs. FL must be greater than Fs. Correct? That is, frequency of sound heard by listener will be greater than frequency of sound actually generated from the source. Now tell me, what is the reason for increase in the frequency? Reason is very simple. When listener and source are moving towards each other, then distance between them will decrease. I told you initially, if distance will decrease, frequency will increase. That's why FL is greater than Fs. Okay? Let us consider now reverse possibility. Suppose listener and source are moving away from each other. Look, listener and source are moving away from each other. Fine. Say listener is moving towards left side, source is moving towards right side. They are moving away from each other. Fine. Velocity of listener is shown by symbol VL. Velocity of source is shown by symbol Vs. Now recall that sign convention. What was the second rule? What was that rule? Very simple. Velocity in a direction from listener to source should be taken positive. Velocity in a direction from listener to source should be taken positive. Now tell me, out of these two velocities, you will find this velocity in a direction same as this direction, so it should be taken positive. But this velocity is opposite to this, so it should be taken negative. Correct? So VL should be replaced by minus VL and Vs should be replaced by plus Vs in the standard formula. Just make these changes in the standard formula. FL upon V plus VL, FL upon V plus VL, but instead of VL I should write minus VL, correct? And that equals to Fs upon V plus Vs, Fs upon V plus Vs, correct? Because Vs is to be taken still positive only. Got it? Find out FL from here, transfer this. So V minus VL upon V plus Vs, V minus VL upon V plus Vs into Fs. Tell me, here also V, here also V. But here you are making subtraction, here you are making addition. Because you are making subtraction in the numerator, it will decrease, and because you are making addition, it will increase, the denominator will increase. So numerator is less than denominator, so ratio is less than 1. And when this ratio, which is the multiplier or coefficient of Fs, is less than 1, naturally FL will be less than Fs. FL is less than Fs. What does it mean? Frequency of sound heard by listener is smaller than frequency of sound actually generated from the source. And why there is decrease in the frequency? Reason is very simple. Because listener and source are moving away from each other, as the time passes on, distance between them will increase. And I told you initially, when distance will increase, frequency of sound heard by the listener will be smaller than frequency of sound actually generated from the source. That's why you are getting FL less than Fs. FL less than Fs. Right? Now, for remaining 4 possibilities, either of these two is at rest. If listener is at rest, then you can take VL equal to 0. If source is at rest, then you can take Vs equal to 0 in this formula. Correct? Come on, let us repeat the definition of Doppler's effect for the last time now. When a source of sound or listener or both of them move relative to stationary air and relative to each other, the frequency of sound heard by listener is somewhat different than the frequency of sound actually generated from the source. Full stop. This very statement is called Doppler's effect. Correct? And which were the two rules in the sign convention? Very simple. Velocity of sound should be taken always positive. That is small v, it should be taken always positive in this standard formula. Correct? And among remaining two velocities, VL and VH, V should be taken positive, V should be taken negative. Very simple. You must remember now. Velocity in a direction from listener to source should be taken positive. If velocity of source or velocity of listener is in a direction from listener to source, it should be taken positive. But if it is opposite, then it should be taken negative. Simple. Velocity in a direction from listener to source should be taken positive. That's all. Got it? Fine. Now kindly read this statement of illustration number 19. Read it? Fine. Now, there is a source of sound in the form of police car, police one or police car, and initially it is at rest. At that time, the wave velocity formula is V equals to F lambda, where this F is frequency of sound generated from the source, and this lambda is the wavelength of those sound waves which are generated from stationary source. Okay, fine. Now this velocity of sound, they have given 340 meter per second. Frequency of sound actually generated from the source, they have given 300 hertz. At that time, wavelength lambda we have to find out. That lambda is 1.13 meter. 1.13 meter. Wait. Now in the second case, you know what have they said? When this police one is moving, correct? They have given the velocity 108 kilometer per hour. Because it produces sound, we will take police one as source of sound, S. And velocity of source means Vs. How much is the value? 108 kilometer per hour. Don't you know? Converting kilometer per hour into meter per second, what you should do? Multiply by 5, divide by 100, divide by 18. Multiply by 5, divided by 18. Remember from the first semester, kilometer per hour to meter per second, you must multiply by 5 divided by 18. Multiply by 5 divided by 18. Correct? That many meter per second. Now 108 upon 18 comes out to be 6. 6 5 is a 30 meter per second. Now they have asked the wavelength of those sound waves which are in the front region, that is in front of the police one, in front of the police one. So in front of this police one, in the direction of motion is this, then in front, the front region will be towards right side, this way, correct? Ahead of this direction of motion, correct? Then you may consider here some listener, correct? They have not given, but we may consider some listener, and because we consider that listener to be at rest, then velocity of listener should be taken 0, correct? If really some listener is there, then what frequency of sound will he experience, and depending upon that we can find out corresponding wavelength. Okay, fine. Now apply standard formula, FL upon V plus VL equals to Fs upon V plus Vs. Recall the sign convention. velocity in a direction from listener to source should be taken positive. Velocity in a direction from listener to source should be taken positive, correct? And if reverse is the direction, then it should be taken negative. Now tell me, this direction of velocity of source is opposite to this direction. Opposite, then it should be taken minus. So Vs value we should take minus, that is minus 30 in this formula, correct? Come on. FL, we want to find out. V is velocity of sound, they have given 340 meter per second. VL is 0, put VL equal to 0. And that equals to Fs, frequency of sound generated from the source, they have given 300 hertz, here it is. Divided by V is velocity of sound, and that they have given 340 meter per second. And I told you velocity of sound should be taken always positive, fine. What about Vs? Because direction of this velocity of source is opposite to this direction, we should take it minus. So Vs is 30, value wise it is 30, but according to sign convention we should take it as minus 30 meter per second. Vs is minus 30 meter per second, correct? Simplify, you will get the value of FL 329.03, this many hertz. Tell me, why this value is greater than 300? Why this value is greater than 300? Naturally, when listener is at rest and source is moving towards the listener, distance between them will decrease. When distance will decrease, come on, frequency will increase, correct? That's why it is greater than actual frequency, which is 300. This is 329, which is greater than 300. Got it? But what is corresponding wavelength? Let us find out. You know V equals to F lambda. Instead of F, I am putting FL. Instead of lambda, I am putting lambda L. Remember, this lambda L is right now wavelength of those sound waves which are propagating in the front region. Okay. Let us find out. Wave velocity they have given 340 meter per second. What about frequency of sound heard by the listener? 329.03 into lambda L as it is. From this we can find out lambda L, it is 1.0333, that many meter. Okay, fine. Now they have also asked, when police car is moving, say this way, at that time what will be wavelength of sound waves in the back side, correct? In this rear region, what will be the wavelength? Let us find out, okay? Behind this police one, what will be the wavelength? Let us find out. Come on. Now listener is here only, correct? Listener is here only, and this source of sound, that is police one, is going ahead this way, correct? Now tell me, if police one is going this way, and if you are looking for wavelength of sound waves in the back region, back side, then you should consider listener on the back side. This is front side and this is back side. Police one we have continued to move in the same direction, correct? In the same direction. But earlier we were looking for the front region, now we are looking for rear region, that is on back side. Fine. Now listener, here also you should take as stationary listener, then velocity is 0. Now what is the sign convention? Velocity in a direction from listener to source should be taken positive. And because this velocity of source right now it is having same direction, I should take it as positive, correct? Fine. Now apply the same formula. Apply the same formula. Come on. FL upon V plus VL equals to Fs upon V plus Vs. Here it is. FL upon V plus VL equals to Fs upon V plus Vs. But this frequency of sound heard by listener in this case is somewhat different than earlier frequency. That's why I am putting different symbol, FL dash. Fine. This FL dash we want to find out. What is V? Velocity of sound, and it is 340 meter per second. What is VL? Because listener is at rest, come on, VL equals to 0. VL equals to 0. Come on, this is frequency of sound generated from the source. They have given in the statement 300 hertz. Velocity of sound is 340 meter per second. Now Vs, because in the same direction of the sign convention, we should take it positive. Earlier Vs value had come out to be in meter per second, how much? 30 meter per second. We should take it now plus 30. So Vs is replaced by plus 30. Simplify. find out FL dash, it will come out to be 275.67, that many hertz. Don't you see? This value is smaller than 300, smaller than 300. Tell me why frequency has been decreased? Very simple. Listener is here and source is moving away from the listener. So as time passes on, distance will go on increasing. When distance goes on increasing, naturally frequency of sound heard by the listener would decrease. That's why this frequency is smaller than 300 hertz. Correct? Fine. Now what is the wavelength of corresponding sound waves? In the backside region, correct? In the rear region, on the backside of the source, what is the wavelength? Let us find out. You know, wave velocity is frequency multiplied by wavelength. Because frequency is FL dash, I take wavelength as lambda L dash. Come on, wave velocity of sound waves 340 meter per second. Frequency of sound heard by the listener on the back side of police 1 is, we have found out, 275.67 hertz, and this is the corresponding wavelength. Simplify, you will get the value lambda L dash equals to 1.233, that many meter. Tell me why this wavelength is more than this. Why wavelength is more than this? Because frequency is less than 300. Frequency is less than 300, correct? And why this wavelength? Why this wavelength is smaller than this wavelength? Because this frequency is greater than this frequency, correct? So what I mean to say, when the listener is at rest and if only source of sound is in motion, then when source of sound is in motion, it may move towards the listener, it may move away from listener. So in both the cases, what happens? There is a relative motion, but in one case distance is decreasing, in another case distance is increasing. That's why frequency may be smaller, may be greater than actual frequency. Depending upon that, wavelength also will be different. Got it? Fine. Now kindly read the statement of example number 20, which is a very good sum. Read it? Fine. You must have read some new word, sonar, S-O-N-A-R. The full name is, this is abbreviated form, it is called acronym. When you pick up first letter from a group of words, then if you are preparing, if you are coining new word, it is called an acronym, and this is an acronym for the phrase sound navigation and ranging. Sound navigation and ranging. In that, you know what we do? We generate sound waves with a frequency greater than 20 kilohertz, greater than 20,000 hertz. And those high frequency sound waves are produced from this system, and those sound waves are traveling in under the sea, I mean in the sea water. And then if any object comes in the way, might be in the form of submarine, then it would be getting reflected. So if the transmitted sound waves are getting reflected, we can come to know that there is some obstruction in the way, maybe in the form of submarine. Got it? Such a system, such a device is known as sonar, sound navigation and ranging. Correct? Because we know the velocity of propagation, we can find out the position of that obstruction. Okay? Then according to, I mean depending upon the frequency of sound which we are receiving, we can calculate the position of that obstruction. Okay? Just to find out that, we have prepared this device, and that device is known as sonar, sound navigation and ranging. Okay? Look. So here is sonar, and there is some submarine at some distance in the sea water. So here I am showing you sonar, here I am showing you submarine. Initially what happens? This sonar, that is this device, generates sound waves. Okay? because it generates sound waves, it will act like source of sound. That is how I am showing here, source of sound. Okay, it generates these sound waves, and they are made incident on this submarine. Instead of submarine, you may think of some listener in that submarine. Some listener in that submarine. So that listener I am showing here. Correct? But they have said in the statement that this submarine is moving towards sonar. Submarine is moving towards sonar. Submarine is moving towards this sonar. So velocity of listener I am showing by symbol VL. Now velocity of submarine means velocity of listener right now, they have given 360 km per hour. Kilometer per hour you must convert into meter per second. Multiply by 5 divided by 18. This value comes out to be 360 upon 18, it is 20, 25 is 100 meter per second. Fine. Now they have asked the frequency of sound as heard by listener in the submarine. Let us find out. Apply the standard formula. FL upon V plus VL equals to FS upon V plus VS. FL upon V plus VL equals to FS upon V plus VS. What is FL? Frequency of sound heard by the listener considered in the submarine, or you may say frequency of sound made incident on the submarine. That's why I am writing here FL. FL is frequency of sound made incident on the submarine. Okay, fine. So this FL we are looking for. Velocity of sound waves in water, it is greater than velocity of sound waves in air, because you know V equals to under root of E upon rho. Rho, density of water is much greater than density of air, that is true. But so far volume elasticity coefficient of water is concerned, as compared to air, it is very large. V equals to under root of E upon rho. When E is very large for water, then naturally velocity of sound waves in water will be very large as compared to velocity of sound waves in air. At present they have given 1450 meter per second. And you know velocity of sound waves is to be taken always positive. So instead of V I am putting 1450, correct? What is this VL? Velocity of listener. And velocity of listener, it is 100 meter per second. And just recall that sign convention. Velocity in a direction from listener to source should be taken positive. Then, because this direction is same as this direction, I should treat this VL as positive. So VL value I should take with plus sign, that is plus 100. Right? What is FS? Frequency of sound generated from the source. They have given 40 kilohertz. Kilohertz you must convert into hertz. Multiply by 10 raised to 3. This velocity of sound waves in water, they have given 1450 meter per second. What about Vs? Because sonar is at rest. Sonar is at rest, then naturally Vs equals to 0. Vs equals to 0. Right? Simplify. This frequency will come out 42,758, that many hertz. Why it is greater than 40,000 hertz? Simple. Source is at rest and listener is moving towards the source. Source is at rest, listener is moving towards the source. So distance will decrease, frequency will increase. Simple. Now in another case, you know what happens? They have asked the frequency of sound waves reflected from submarine. Reflected from submarine. Let us find out. See, when sound waves are propagating this way, look here this way. You may consider source over here and you may consider listener over here. Okay. The same situation I have shown in this diagram. Source I am showing here, which is actually submarine, and the listener I am showing here, which is, you may take person in this device, that is sonar. Now because sound waves are getting reflected this way, as if they are coming from this source and they are reaching towards this listener. Same diagram I am plotting here. Here is a submarine, which is a source of sound waves now, and now this is a listener. Come on. So now sound waves are propagating this way, look, correct? And velocity of source, because source is right now submarine and submarine is moving towards stationary sonar, then velocity of source I am showing V as this way, correct? But you know, according to sign convention, velocity in a direction from listener to source, velocity in direction from listener to source should be taken positive. But because this direction is opposite to this, I should take this value as negative. Now remember this. Now apply standard formula, FL upon V plus VL equals to Fs upon V plus Vs. But we are looking for frequency of sound waves reflected from submarine. It is different than this frequency. That's why I am putting different symbol, FL dash. So I am putting here FL dash, correct? Now tell me, put the values. FL dash as it is. What about velocity of sound waves in water? They have given 1450 meter per second. You know, velocity of sound waves is always to be taken positive. So here also with plus sign, here also with plus sign, correct? What about VL? VL is velocity of listener. Now here is the listener, it is at rest, so velocity listener is 0, VL is 0. What about Fs? Fs is frequency of sound wave, remember, generated from this, correct? Actually the sound waves are not generated from here. So what you should take? Tell me first of all, which sound wave will be reflected? Which one will be reflected? The one which is made incident. Which sound wave will be reflected? The one which is made incident. Now tell me, when the sound waves were incident, what was the frequency? Frequency of sound waves incident, it was this frequency. Earlier we have found out in the previous case 42,758. So now this frequency is right now 42,758, and then after, while getting reflected, that frequency will be experienced by this listener. That is what we have to find out. So we are looking for value of FL dash. This is the frequency of sound wave which is made incident on the submarine, and that frequency is this, which is 42,758. Velocity of sound wave in water 1450 meter per second with plus sign. What about Vs? Look, because this direction is opposite to this, I should take this Vs as negative. Earlier Vs value was velocity of submarine. Velocity of submarine, they have given 360 kilometer per hour, but we had converted that value in meter per second, it came out to be 100. But right now, because it is having direction opposite to this, we should take it as minus 100. So Vs is right now minus 100. Vs is minus 100, correct? Simplify, find out FL dash. FL dash will come out to be 45,925, that many hertz. This frequency is of which sound waves? This is the frequency of sound waves, look, reflected from submarine, correct? And this frequency of sound wave is frequency of those sound waves which are made incident on the submarine. Incident sound waves have this much frequency, reflected sound waves have this much frequency. Why this frequency is greater than this? Why this frequency is greater than this? Reason is very simple. Sonar is here, it is at rest. Submarine is constantly moving towards sonar. Tell me, as submarine is moving constantly towards sonar, then distance between them will go on decreasing, correct? But as the distance goes on decreasing, the sound wave will take lesser and lesser time to reach the sonar, because when distance is decreasing while being incident and then after while being reflected, the sound wave will have to travel gradually lesser and lesser distance, and that's why it will reach the sonar earlier and earlier. And because of that additional relative motion, the another increase in frequency is there, and that final frequency we got this much, 45,925 hertz, correct, which is greater than 42,758. This is frequency of sound waves made incident on the submarine. This is frequency of sound waves getting reflected from submarine. Got it? Fine. Now we go for exercise MCQs. Exercise MCQs, okay? Kindly read the statement of first MCQ. Read it? Come on. In case of propagation of mechanical waves in a medium, what is being propagated along with the propagation of wave? Energy. You know, waves do carry energy with them. So, in whichever direction mechanical wave is propagating, in the same direction we have propagation of energy. So, answer is energy, correct? Read now number 2. Read it? Wave velocity is frequency into wavelength. Frequency into wavelength. Wave velocity they have given 330 meter per second. Frequency they have given indirectly. They have said that pronges of tuning fork vibrate 256 times in 1 second. And you know, number of oscillations completed in unit time is called frequency. But if that unit time is taken 1 second, then that frequency is said to be in hertz. So, how much it is? 256 hertz. Lambda we are looking for. Lambda you will get from this 330 upon 256. Answer is 1.29 that many meter. Okay. Read now number 3. Read it? Fine. You know, maximum velocity is given by this formula A omega. Actually, tell me, during the propagation of transverse harmonic wave, you know, the particle of medium is oscillating this way, up and down, perpendicular to direction of propagation of wave. And when that particle is performing simple harmonic motion, what was the expression for velocity of particle? What was that? Vp. Remember, Vp equals to A omega cos of omega t minus kx. But because you are looking for maximum velocity, A omega cos of omega t minus kx, in that cos of omega t minus kx should be taken as 1, because maximum value for cosine function is 1. So, A omega into 1, that is A omega. Okay. So, this is not simply velocity, this is maximum velocity, not of the wave, maximum velocity for oscillation of particle, correct? Now, A as it is, what about angular frequency? It is frequency multiplied by 2 pi radian. This amplitude they are given indirectly in the form of maximum displacement. You know, maximum displacement is nothing but amplitude, they have given 0.1 centimeter. Because this A value is in centimeter, this velocity will be obtained in centimeter per second. 2 pi as it is, frequency they have given 300 hertz, answer is 60 pi. And because with this value you are taking in centimeter, this velocity will be measured in centimeter per second. Okay. In the options, if they are keeping pi as it is, then in this formula also you must not put the value of pi, you should leave pi as it is. Okay. Final answer is 60 pi centimeter per second. Kindly read now number 4. Read it? Come on. Delta equals to 2 pi x upon lambda. What is the delta? Phase difference between two particles separated by distance x along the direction of propagation of wave at a given instant of time. Okay, come on, lambda is wavelength. Now 2 pi x as it is. Don't you know formula? V equals to f lambda. V equals to f lambda. What is lambda from that? V upon f. Lambda is V upon f. So denominator's denominator will become numerator. Correct? Now this delta, which is phase difference, which is some sort of angle, you must write in radian, because this 2 pi is in radian. Okay, come on, delta value, phase difference, they are given 60 degree. Don't you know, degree to radian, you must multiply by pi divided by 180. Come on, degree to radian multiply by pi upon 180. Pi upon 180. This 2 pi x as it is. What about frequency? They have given 500 hertz. What about wave velocity? They have given 360 meter per second. Simplify. Answer is x equal to 0.12 meter. X equals to 0.12 meter. Okay. Because all the values are taking SI unit, no? Then this distance, this separation between two particles you will get in meter. Fine. Come on. Read number 5 now. Read it. They have given one graph, and what is that graph? It is the graph of displacement of particle of medium along the direction of propagation of wave versus distance of that particle from the origin of that wave. Okay, it is a graph of y versus x, and that graph also indicates the shape produced in the medium during the propagation of one dimensional progressive harmonic wave. And the shape is like this, correct? Now tell me, from here to here, it gives you one wave completely, one crest and one trough, means one wave completely. So here it is one wave, another wave, and then half of the wave. Only crest means half of the wave. So what is the number of waves in this much length? Come on, from here to here it is 1, 2 and then half. 2 plus half. 2 plus half means 2.5. Okay. How many waves? 2.5 number of waves. Now let us find out wavelength lambda. Wavelength lambda is nothing but given length divided by number of waves in that length. Given length is how much? 0.25 meter divided by number of waves in that much length is, as I said, 1, 2 and half, that is 2.5. Correct? Given length divided by total number of waves in that length will give you length of one wave, which is called wavelength. Correct? 0.25 upon 2.5, answer is 1 upon 10, that is 0.1 meter. Wait, don't you know wave velocity formula? There were two formula, I told you to remember. V equals to f lambda as well as V equals to omega upon k. Come on, use this formula, omega upon k. Omega as it is, what about k? K is 2 pi upon lambda, wave vector 2 pi upon lambda. Now this lambda will go up, correct? Put up the values, wave velocity is 330 meter per second, omega we are looking for, lambda we have found out, it is 0.1, 2 pi as it is. Now find out omega. Omega will get this much, 6600 pi radian per second. 6600 pi radian per second. What about wave equation? For a wave propagating along positive x-axis, y equals to a sin omega t minus kx. Wait, a value, that is 0.05 meter. How? You can see in the diagram, this much is maximum displacement, and maximum displacement is nothing but amplitude. They have given in the figure 0.05 meter. So this a is 0.05 meter, sin as it is, omega we have found out 6600 pi. 6600 pi into t, don't forget, minus k. K is 2 pi upon lambda. wave vector k is 2 pi upon lambda. 2 pi upon lambda, lambda is 0.1 meter. 2 pi upon lambda, lambda is 0.1 meter into x. Simplify now, 0.05 as it is, sin as it is. From these two terms, I can take 2 pi common. Then left inside the bracket from here, it is 3300 t minus left inside the bracket from here, because 2 pi has gone out, left is x upon 0.1. 0.1 means 1 upon 10, 10 will go up, 10 into x, correct? That many meter, because this amplitude you are taking in meter, correct? Whenever you are asked to obtain wave equation, you should leave these variables as it is. Right now x and t, they are variables, leave them as it is, and then this is the formula. All that you have to find out while obtaining wave equation are the constant values. Constant values you can find out, the variables you must leave them as it is. Got it? Kindly read now number 6. Read it. Y equals to a sin square kx minus omega t. Now tell me, we are asked to find out amplitude and frequency in this case. Let us find out this way. A as it is. Take this bracketed angle as theta. Then it will be sin square theta. Don't you know formula of sin square theta? 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. That is 1 minus cos double by 2. 1 minus cos double than this, that is 2 kx minus 2 omega t divided by 2. Fine. Now this a by 2 into 1, that is a by 2, correct? Minus a by 2 into this, a by 2 into cos of 2 kx minus 2 omega t. And now take this y on right hand side, take this part on left side, will become plus. So when you take y on right hand side this way, then a by 2 minus 1, here I am writing a by 2 minus y, correct? And this part when you take on left side from minus, it will become plus a by 2 cos of 2 kx minus 2 omega t. Now this is constant part and this y is displacement. From this constant part, if you just subtract the variable value of displacement, at each moment you will get variable value of new displacement. So this a by 2 minus y, it indicates new displacement, let it be shown by symbol y dash. So in place of a by 2 minus y, I am writing y dash. This right hand side as it is, okay? And now tell me, what is amplitude from here? Don't you know, in the expression of displacement, the coefficient of periodic function in terms of time gives us amplitude. Periodic function in terms of time is right now this cosine function, and its coefficient is right now a by 2. So this a by 2 will be amplitude for this considered motion, correct? What about frequency? Frequency is nothing but angular frequency divided by 2 pi. Don't you know formula? Omega equals 2 pi f. So what is f? Omega upon 2 pi. Speak out in words. Angular frequency upon 2 pi. Angular frequency upon 2 pi. But what is angular frequency here? It is the coefficient of time in the bracketed part with periodic function in terms of time in the expression of displacement. Correct? In the expression of this displacement with this periodic function, you find this angle, and in that the coefficient of t is 2 omega. What is it? 2 omega. So right now angular frequency is not omega, but it is 2 omega, but angular frequency divided by 2 pi will give you frequency. Now 2 will cancel, giving you frequency omega upon pi, omega upon pi. Frequency has the unit hertz and angular frequency has the unit radian per second. Got it?